Hello all. Good afternoon, good morning. Welcome to another session of Azure Community Terraform. Today we have a theme called cloudnative. So it's going to be on Flux and Terraform, and will be on AKS. So let me just present some housekeeping for us. Okay, so yeah, so let's see. Sorry, subside. So just code of conduct. So all members of this group should abide by this code of conduct. Be friendly and welcoming to everyone. Be patient. Be thoughtful. Be respectful and inclusive. Be open and curious. So always ask questions to understand something that you're unsure about and not to criticize one another. And the agenda today is, apologies for this, is Flux and an AKS. So it's going to be done by Robin Smogberg, sorry, I pronounced it wrong, and he's a principal cloud architect and a Microsoft MVP doing Terraform with Flux, followed by Richard Cooper and Wesley Hartman, who's also both principal cloud architects at Intercept, and is also MVP at Microsoft Azure MVP. And they're doing a session called Node Autoprovision on AKS. And next session is on the 22nd of this month, and we're having network theme. So two amazing speakers joining us from the community. So Joe Colley is coming to a session on networking BCDR, and Adrian Finn on Azure Firewall. So let us introduce our speakers. So we will have Robin first. Hello, Robin.
Hello.
How
are you? Multitasking.
How are you doing? Yeah,
I'm good,
multitasking.
I'm good. And name is Robin Smorenburg if you want to stick to Dutch completely. English doesn't sound that great. So yeah. Anyway.
So if you want to share your screen, I can put it up in a minute.
Let me do that. Share screen, entire screen. There we go. Let me know when you pull it up, because then I can move to a different tab. Or let me move this.
Cool.
Yeah, there we go. All right, let me move you to this tab. Let me switch this here. Let me move this as well to participate in chat. All right, so screen is visible. Good.
Okay.
All right.
Yeah. So, would you like to take question on a shout or at the end, Robin?
You can weave them in, so that's fine.
Okay, cool.
We can take them on the spot. So
yeah,
and that goes for you, but it goes also for the gents in the green room, right? So Richard and Wesley
anyone,
are there.
Richard, Wesley. Yeah.
All right, but then let's get started. All right, so welcome to this session, which is called Using Terraform the GitOps Way. For today's Azure Community Enthusiast User Group session. Oh, like Nick already mentioned, and I already corrected him. My name is Robin Sporenburg. I'm a principal cloud architect at NorCloud, Azure MVP, and I was a CNCF ambassador, or I am a CNCF ambassador, depends on the outcome of the renewal. So today's agenda, we'll briefly discuss GitOps. Then we talk 3 hours about Kubernetes. Then we briefly discuss Terraform. We talk about Flux. Then we talk about the snippet box, which is a demo application that I use for the demo. And then we have the demo. So let's get started with GitOps. All right, so GitOps is a framework that takes DevOps best practices used for application development and applies them to infrastructure automation. So what does that mean? All right, so basically your repo is the source for your infrastructure. Usually used within Kubernetes. So let's look at the GitOps principles. All right, so we have continuously reconciled, pulled automatically, versioned and immutable, and declarative. So declarative means the desired state of the system is declared in a Git repository. All right, so you have declarative and you have imperative, right? Where imperative, you basically define the steps that you need to take, or that the system needs to take to reach the desired end result. And then you have declarative, where you basically define the end state, and then the system figures out the steps that that it needs to go through to achieve that. So it's declarative, right? Terraform is declarative. ARM templates, declarative. Bicep, declarative. Kubernetes YAML files, declarative, right? So that's the first principle. Then the second is versioned and immutable, which facilitates auditing, collaboration, and eventually, if needed, rollbacks, right? So because you store all your code in a repo, it's by default versioned, right? And by default immutable. You can change it through commits, but you can also roll it back, right? And then pulled automatically. So there's an agent for today's session that's Flux. There's another one which is called Argo, right? Or Argo CD and Flux CD to be more specific. But that agent runs in the cluster, monitors for any changes, and then pulls the changes in. Right, so the agent monitors your repository for any changes, and then if detected, it pulls these changes in, and instructs the Kubernetes basically to achieve that desired state. And then the final piece is continuously reconciled, which means that that pulled automatically that I just discussed happens on a schedule, right, on an interval. So in today's demo, we will be using Flux, and we will be using the Tofu controller, which was previously known as the Terraform controller or the TF controller. And that one in today's demo will reconcile every 10 minutes. So every 10 minutes, it will figures out if there are any changes, and if so, then it will trigger Terraform to act on these changes. So then Kubernetes. Right, it's the open source system for cloud native applications. You can automate your deployments, you can scale and manage your containerized applications. It's basically a data center in itself, VMware on steroids, where we virtualize a container instead of a virtual machine. But it's basically a hypervisor platform for containers. It comes with a lot of features like an API that you can talk to, a scheduler that provides that reconciliation loop that I just talked about, and a lot of other features. Right, it's extremely extensible. So you have something which is called custom resource definitions, CRDs, enabling you to extend the functionality or the features of your platform, like Flux, for example. And I believe my mic is crackling a bit. I hope. Weird. There we go. Okay. So let's briefly talk about the Kubernetes components. So we have the Kubernetes cluster, which is the big gray box that we're currently looking at. And then we have something which is called a control plane, which, well, it's in the name. It controls basically your Kubernetes cluster. So it's the brains of your cluster. There are a lot of different components in the cluster, like the API that I just discussed, an etcd, which is basically the database, which saves or persists the store of your cluster. Right, so there it keeps track of your cluster and its configuration. And then you have your nodes, which are basically the light gray boxes on screen. Every node is an instance or a virtual machine, right? And your control plane runs on virtual machines as well. And the nodes is where basically your application gets scheduled by the Kubernetes scheduler, and then it gets deployed, and then it spins up and so on and so forth. But there are a lot of different components to a Kubernetes cluster. And when using AKS, for example, Azure Kubernetes Service, there's also a cloud provider API, which enables Kubernetes to create, for example, a load balancer, because you need traffic to be able to flow into your cluster, right? Or things like a virtual disk or a managed disk, right, to store data if needed. So then a big topic of today's session is cloud native beyond Kubernetes. So what do I mean by that, right? So if you look at Kubernetes, then your app usually runs in Kubernetes, which is then the runtime for your application. But it can be that you need some resources outside of your cluster, right? Some infrastructure to support your application, like, for example, a storage account or an Azure cache for Redis, right? So in today's demo, you will see the vote application that we all know, right? The Azure voting app, dogs and cats. right? Or cats and dogs, whatever you prefer first. But that one uses an Azure Cache for Redis, which I already deployed. But if you deploy that without any modifications, it will give you a Redis cache as a container in your cluster, right? But then you need to manage that. You need to manage the state. You need to take care of that, right? So if you then use a PaaS service, right, platform as a service, like Azure Cache for Redis, then you don't have to do that, right? The same for database for MySQL or Cosmos DB, Event Hub, right? And so on and so forth. So cloud native applications are more than just Kubernetes, right? So we need a way of deploying that, and that's where Flux comes in later on. So let's briefly talk about Terraform. Probably most people that are watching this right now already know what Terraform is. But just to make sure that we have all the pieces, I will just briefly discuss it. Right. So Terraform is an alternative for Bicep. It's an infrastructure as code tool, which enables you to provision infrastructure in basically any cloud provider. It's usually referred to as multi-cloud. Well, and that is usually interpreted as, okay, I write my code once and I can deploy this to different clouds. Well, that's not the case, right? You can use the same tool for every cloud, but you need to rewrite your whole configuration file. All right, so in a way, it is cloud. It is multi-cloud, but not in the way that people usually tend to think it is. So then the Terraform workflow, right? So we have me on the left there, minus the glasses and the beard, but okay. All right, so you do a Terraform plan where you basically plan the configuration, your infrastructure, followed by a Terraform apply, right? So if you're happy with the plan outcome, then you run Terraform apply. Terraform is written in Terraform manifest files or .tf files, and it's written in HCL, which stands for the HashiCorp configuration language. Then Terraform uses providers and provisioners, like highlighted in the middle, to make it extremely extensible. Right? So there's, for example, a Kubernetes provider and an Azure provider, which we will both use today. Right? So the Azure provider to create Azure resources, or basically that's what I created. That's what I used to create the cluster that we'll be looking at today, right? The AKS cluster. But then we also be using the Kubernetes provider to create Kubernetes resources using Terraform. Right? So then you can create Azure resources and Kubernetes resources using Terraform. I believe it's now available in Bicep as well. Well, we don't have a Bicep controller, right? So maybe that's something from the roadmap. And then we have different provisioners, but let's not go into that. Terraform uses state file, which is a curse and a blessing, right? Has pros and cons. But that's a file we can reference, right? And that's a file that keeps track of the state of your infrastructure, and that's also the file that's being used for any drift detection or reconciliation. And then it, like I already briefly highlighted, it supports multiple cloud providers. This is a small list, but it supports a lot more. Then Flux. Flux is the GitOps operator, enabling. Geez, I cannot talk today. Long day. Enabling you to implement these GitOps principles that we just discussed. Right. So let's briefly discuss the Flux workflow. So I commit a change to my repo, right? Then Flux detects and triggers a synchronization. The cluster updates based on the desired state in Git, which is being communicated from by Flux to the cluster, and then the status is reported back to Flux. Right, so from commit to Flux, from Flux to the cluster, and then the cluster reports back to Flux. And then this happens on an interval that you configure. Then some of the components, right? Flux has this concept which is called controllers, right? So these are some of the controllers, the ones that are installed by default. There are other controllers, like a notification controller. Nick, let me know if there are any questions, right? So let's briefly talk about the customize controller. So you use customize to piece everything together in your repo. So Flux searches for customization files and then goes through your repo, right? And then you can use customize. We'll look at that to define what files and what folders you want to include, so that Flux uses these files and folders. And we have a source controller, right? The controller that is monitoring your source, like GitHub in today's example. But it supports GitLab, it supports Azure DevOps, it basically supports every Git implementation. And then we have the Helm controller. So we can also work with Helm charts. The cluster is using Helm charts, right? So, well, Flux is using Helm charts to install different infrastructure operators in the cluster, like Nginx, right? Ingress controller, or Cert Manager for a certificate, or the Terraform controller, right? So Flux uses Helm to install an additional controller, which is called the Terraform controller. Well, Tofu controller, right? So they recently renamed it. It used to name the name used to be the name used to be Terraform controller, and now it's Tofu controller. So there's a new update. I didn't install the update because I like it when my demos work. So I just minimize the risk, right? But what it does, it monitors, it talks to the source controller, right? Like you can see in this diagram. And then the Terraform controller spins up a runner, a Terraform runner, which is basically a pod that includes the Terraform binary, right, in the Azure CLI to be able to authenticate as well. And then it goes ahead and uses a managed or sort of a workload identity, which is basically a managed identity, to authenticate to Azure, and then start deploying some of the resources outside of the cluster if need be, right? So that's something we'll do today. In this diagram, you see a secret in TF plan, which is still the case, and a secret in TF state. And that's not the case. We're using a storage account. So the Tofu controller supports a remote backend where you can save your Terraform state. Right, and the Terraform controller is installed using Helm, like I mentioned. Let's see, are there any questions? All right, Flux versus Argo. Hey, Paco, nice to see you. So Flux versus Argo CD, is there any use case where you would choose one over the other? That's a good one. Now with the whole Weaveworks situation, which is mostly cleared up, so Flux is now completely community maintained, but it's not part of Weaveworks anymore. I tended to, lean towards Argo, but yeah, I still prefer Flux for bootstrapping my cluster, and then install Argo with Flux. I believe that Argo can do that as well, but I don't know. I like the lightweight feeling of Flux, but they both can do GitOps. Argo has something which is called Argo Workflow, where you can basically orchestrate CI and CD pipelines, and there's some pros and cons to choose one over the other, but they both do a pretty good job at GitOps. All right, and let's move on. So the Snippet Box app, it's a containerized app written in Go, which uses a MySQL database. Right, Nick?
Robin, I want to ask you a question.
Yeah, go ahead.
Can you go back a slide, please?
Yeah, sure.
You said the secrets are stored in a TF state. Is that where? Why is there two?
Well, one is the plan, right? So Terraform runs a Terraform plan.
Yeah.
And then it runs a Terraform apply, right? But between these two, so it runs a Terraform plan, then the runner is killed or removed. Let's stay away from kill. So the runner is removed, right? And then it comes back up, and then it executes a Terraform apply. In today's demo, that is completely automated. So it auto approves your plan. But you can also have that outputted to GitHub in a pull request, for example. And then you can review your plan before you approve it, right?
Yeah. So in this instance, the TF runner is communicating to the Terraform cloud, the cloud provider?
No.
Or is
no.
Okay.
No. No. It's
Like, okay.
it. So the repo that Flux is monitoring has Terraform
Yeah.
code in it. So
Yeah.
I basically tell Flux where he can find Terraform code, and then the Terraform controller takes it over.
Okay. Since
Right? And
it doesn't call Terraform controller now, it's just called Tofu controller, right? Don't want to install it on the
yeah. Anyway,
Flux.
TF controller,
Okay.
right? That fits
Oh
both.
yeah.
But yeah, you're right. It's now
Yeah.
officially called the Tofu controller, not the Terraform controller anymore. But it supports Terraform and Tofu, right?
Okay.
Or it will support Tofu. I'm not sure about that yet, or they just changed the name. But anyway, yeah, and Damien, you're right. Argo does not have the Terraform controller. Yeah. All right. So back to Snippet Box. So it's a pretty bare bones application. It's written in Go. I did that following a book which is called Let's Go, which will take you from zero to hero in writing production level web applications in Go. It's not finished yet, right? Time constraints, stuff like that, but it's good enough to demo today's functionality. And it uses a MySQL database. So we'll be using Azure MySQL PaaS service instead of a MySQL database running in a container. There is a container containing MySQL, but that's just used to normalize the database schema. But more about that in a second. So I'll briefly talk to the deployment steps to set the stage for the demo, and then we'll go into the demo. And then we'll start with the repository, so I can walk you through what it is I've set up. And then we'll deploy then we commit the snippet box application to the repo, and then Flux will pick it up, and then the Tofu or Terraform controller comes in, right? So first, what happens when the Terraform runner comes up and it starts running Terraform plan, then it will generate and create the key vault secrets. So I'll do that with Terraform using a random provider. Then it will create the Kubernetes namespace using the Kubernetes provider. It will create the MySQL deployment, which is a Kubernetes deployment, right? Because I need a MySQL database, or I need a MySQL instance to normalize the database schema, because the snippet box needs a database and specific table configuration, right? So I want this completely automated from end to end. So that means that I also need to work with the database. Right? So after my database server, my SQL server is there, then I still need to create a database, the tables, and so on. So I use Terraform for that. That's another provider, which is called Atlas, not to be confused with MongoDB Atlas. Right? So create the MySQL deployment. So then that MySQL pod is just waiting there to be used. Right? Create the MySQL service, because I need to be able to talk to my MySQL deployment. Then I create the snippet box service, which will not do anything until the snippet box deployment is done in the final step. Then I will create the ingress rules and request the certificates using Cert Manager. Provision the Azure database for MySQL flexible server. So that server is then empty, right? There's no database schema or anything like that. Then I configure the server firewall, because otherwise we cannot talk to our MySQL flexible server. Right? Of course, when you integrate everything with private endpoints and so on, then you don't have to do that. But I haven't done that for this demo. Then we normalize the database schema with Atlas. So this can be a little bit confusing in the demo. We'll take a look at this, but there is like a vanilla MySQL container running in Kubernetes. No authentication, no data, no disk or anything like that. So there's no way of persisting your data. But that one is just used so that Atlas knows the target database, or the target database server version, and then it normalizes that, and then it connects to the MySQL flexible server to apply that database schema. All right, then it creates the database and the tables using that schema, and then eventually, when everything from 1 to 10 is done, then all the prerequisites are done, then I can create a snippet box deployment, because that one won't come up if my database is not there. Right? Then it will just retries until eventually it backs off. All right, enough slides. Time for demo. Let's see. This one is still, yeah, okay, it's still here. Good. Okay, portals here. Let's start in Visual Studio Code. I hope this is big enough, or do I need to enlarge it?
Maybe just zoom it once. That's it.
Once?
But I think it's okay for now.
It's already zoomed slightly.
Yeah,
But I can
okay.
make it a little bigger. Then Nick, it's just like at the optician. Is this also big enough, or do I need to enlarge this?
That's fine. I can see
that's
it.
fine. All right, good. Then let's double check with this one. Let's zoom this one as well. All right. And let's get back to Visual Studio Code. So I have a repo which is called Using Terraform the GitOps Way. And this one is a public repo on GitHub. All right, let me get rid of this as well and switch back.
Robin, I think Richard said you want it bigger.
Bigger?
just zoom in.
All right. There we go. So there's a README file in that repo, basically, describing all the steps. We won't go through this right now, but what this basically does is deploy the AKS cluster, manage identity, public IP address that we need for the Nginx ingress controller, and eventually after that's done, you install the Flux CLI, and then bootstrap Flux. But that's already done. Right? For time's sake, this is already done. We will look at the cluster though. Then there's the Terraform code, with the code for the cluster, the key vault, and so on and so forth. And there's a script for creating a storage account for your Terraform state, right? Because you need to save your state somewhere, and if you try to do that with Terraform, you end up with the chicken and egg or hen and egg problem, right? So that's one. That's the first step. This deploys the infrastructure that we need. So and that will bootstrap Flux as well, right? And Flux will look at another repo which is called Using Terraform the GitOps Way source. So this is my source repository, which then will be monitored by Flux, right? So then let's switch to the source repo. So this is another repo. This is the one that ends on source. This has a README as well, a lot of steps, like you can see. Only a title, and this one has a Flux setup in terms of customization files and directories. So let's start with clusters, right? So if I bootstrap Flux, then I need to instruct Flux where to place its own configuration file. So Flux stores its configuration in the same repo that it monitors. All right, so and you do that in your Flux command. So here I have path clusters, right, which is basically this folder in the source repo, clusters. Then it creates this Flux system folder and some Flux, some Flux configuration files, but we won't go into these. And then it looks at these two files in that folder that were already there. So it looks at infrastructure and it looks at apps, where infrastructure is a prerequisite or a requirement for apps. All right, so this is what happens when it goes through the infrastructure file, and then it detects like, okay, this is a customization, right, which is built into Kubernetes nowadays. It's part of the kubectl as well. So it knows what to do with this, right? Then, oh, by the way, that's not true. This is a customization, Flux CD specific customization file, which is installed when you bootstrap Flux, right? So when you bootstrap Flux, it installs all the Flux components, the controllers we discussed, right? And then it also installs some CRDs and stuff like that. So this is the info controllers, which looks at another path, right? Infrastructure/controllers, which is this folder here. So they already see that you can use a customization file to point to another directory, right? So that one points to this directory, and then specifically controllers. And then when that one's done, right, because this one has a dependency, depends on info controllers, then it goes to infrastructure/configs, which is this one. And then it will install a cluster issuer and a network policy. And why is this split up and why is there a dependency? A cluster issuer depends on cert manager being there, right? And cert manager is installed here. So you need a way of iterating through this, of defining these dependencies, because otherwise it tries to install or it tries to create a cluster issuer while that CRD is not there yet, right? So it takes care of that, then it takes care of this, and then it goes to apps. And apps has a dependency on configs, right? So infra controllers, infra configs, and then apps or applications. And this one goes to /apps, right? Which is this folder, where we have a snippet box and a vote app. So it goes into this folder, it detects this customization file, which basically says, okay, include the vote folder, but don't include the snippet box folder. So what you will see soon is that we have a vote application deployed, but we don't have a snippet box application yet. And all I have to do is to trigger the whole process, add another line here, hyphen snippet box. And then, like I briefly mentioned, we install some controllers to make all of this possible. So we have a Terraform controller, which is installed using, I believe, Helm. We have a cert manager. We have an Ingress controller in the form of Nginx. And we have a Weave GitOps dashboard, which is still Weave works, but hopefully they will modify that as well. And then we have the apps here. So before I'm going to trigger snippet box, let's take a brief look at the dashboard, right? So let me log in, very secure. No, it's not admin, but it's very secure. Now you can only access this from within the cluster. So I'm having there's a port forwarding active, and I can only access this through a port forwarding. So there's no service exposing this. There's a network policy in place as well. Admin 123. No, it's admin Flux. It's defined here as well, by the way. So if you go to Weave GitOps, then you see here, change password by generating new hash. Bcrypt hash for password is Flux. So in a way, I basically committed a secret to my repo, right? But anyway, it's all demo. Don't do this in production. And I'm not a financial advisor. No, I'm joking. So okay, let's move on. So this is the dashboard, right? This is not installed by default. So Flux primarily is an application or a controller or a tool that you interact with through the CLI. Right? So there's a Flux CLI that you can use, and there's also a TF-CTL that you can use, so that you can interact with the Terraform controller, because sometimes it gets stuck, or your state file is locked, or you want to approve a plan or anything like that. And these are basically all the components we just discussed, right? So there's a Helm release for a Terraform controller. Let me sort this on name, otherwise it keeps jumping around. All right, let's start at the top. So we have apps, which is a customization, which basically says, okay, I have one app which is called Vote, right? After that, we trigger or add snippet box and commit that, then you will see snippet box appear here, and then you will see that it will start deploying. Okay, sorted that name again. Now I have the cert manager, which is a Helm release, right, which is installed. You see status is ready, right, and also a message, install succeeded. We have Flux system. That's Flux itself, basically. So Flux is managing itself through Flux, right? Then we have the infra configs, the infra controllers. We have the Nginx Ingress controller, the Terraform controller, and the dashboard. So let's go to repo customization. Let's add snippet box. Come on, snippet. Come on, GitHub Copilot. Not working today. All right. Save that and let's commit that. Add snippet box. Okay. And there my codes again. Such a setup, and still have funny weird issues. There we go again. Oh no, have to maybe rewire everything. But what you see here right now is that Flux has already detected the change, and now it says, okay, I have some dependencies that I need to wait on. All right, so infra configs has a dependency of controllers. Controllers is now done, so we can trigger this again. All right, we can say resume selecting. There we go. And then we can trigger apps. Right now it says, okay, there we go already. And here we see snippet box now. So we added snippet box, we committed that, and now it starts applying or planning snippet box initially, and then it will start applying the snippet box. All right, so let's go to the cluster. There we go. Let's go to pods. Let's make sure this is sorted. Yeah, there we go. And here you see the snippet box Terraform runner that already came up. So it knows like, oh, this is for the Terraform controller. I need to do something with Terraform. So run a Terraform plan that is automatically approved, and then it start running a Terraform apply. Yeah, probably already. Maybe it's my headset, or I don't know. It's fine. I'm happy that you can hear me just fine. All right, let's look at this one. So here we basically see, for anyone who is familiar with Terraform, I can basically press here as well, that this is what you will see if you run a Terraform plan and a Terraform apply. So these are all the steps that we already went through, right? 1 to 11, where you basically generate some random IDs and some secrets. We'll create some namespaces and services and so on and so forth. And then we need to wait on the database server. All right, there we go, MySQL flexible server. So while this is deploying, let's go to the portal. Let's refresh this. And here we have the voting application, right, which we discussed with a Azure Cache for Redis, which was already deployed, because this one takes approximately 20 minutes. And even though I like to talk, this is fun, 20 minutes waiting for something to deploy I don't think that is very suitable, right? So this is what's being deployed right now. The RG, my mic is echoing. It's weird. Should not be. Nick, am I still good?
Too bad. I can hear you.
Yeah, okay, but there's a difference between, can you hear me or am I? Okay, can hear fine. All right. I don't know. I'll get this checked out. I'm sorry, guys. Better than Nick's. All right. Anyway, this resource group was created by Terraform, and now it's deploying that that SQL server in the backend. Right, it takes about 6 minutes to complete. But yeah, this is while we wait. All right, let's briefly look at the resources that are already created initially. Right, so there's an AKS cluster, there's a container registry, there's a managed identity that is assigned to my kubelets on my nodes. Then there's a Terraform controller managed identity, which we assigned. Okay, I'm distracted by the chat. Okay, my audio seems to be good. But this is this is used through a workload identity, right? So the TF runner that is currently running to the deployment is using this managed identity, which has contributor permissions on this subscription to create a resource group and do the deployment of what it needs, right? A key vault to store the secrets, right? So if we look at this, there is a automatically generated MySQL login and password, right? Which I did in Terraform as well. So there are not any secrets or anything committed to that specific part of the code, right? If we forget about the admin Flux b hash that I committed to the code, this is all generated at runtime. Repo when this code can be found. Yeah, I can do that. Let me do that immediately. Repos. Oh, that's basically this one and this one. And I think I have that still open in YouTube. There we go. That's one. That's two. All right. So yeah, these are basically generated at runtime. Right? And also one of the benefits of handling Azure and Kubernetes resources in Terraform, that's basically only benefit, because usually I don't do it, but now with the Terraform controller, there's a reason to do it, right? Let me show you what I mean. It's easier. There we go. Snippet box, Terraform main. So this is basically the Terraform code that is currently running in the background, which deploys everything that we need for snippet box. But it also creates all the Kubernetes resources, right? So it uses the Kubernetes provider for that. There's a time provider that I used to add some sleep somewhere because it sometimes takes some time to replicate. But yeah, the Azure RM provider and the random provider, and then the Atlas provider. I need to start working on version 0.8, but then I need to bake in the Atlas CLI into the TF running container image, where I'm now just running, we're just using the standard TF runner image, right? So I stack to 7. Then, yeah, we define the provider. We have a remote state. Well, let's not look at all this stuff. Right, one of the benefits here is that because you deploy your MySQL flexible server, you can use then the resource. You can then use output from that resource as input into another resource, right? So I don't have to save that into a key vault and then pull it out again. I just handle all of that in Terraform. So you will see that here. So let's scroll to, let's see, MySQL schema, Snipperbox service, Ingress rule. Oh, I went over it. Service, Snipperbox, there we go. So the application, the Snippetbox app needs an argument, which is called DSN, database. Now I cannot find the name. Anyway, this argument is needed when the Snippetbox application comes up, right? /DSN, and then it's using local.dsn, right? And if we go to local here, command locals, and then we go to DSN. Then you see, oh, there it is, data source name. That's what it stands for. Construct the data source name. And then it uses information that I also save to the key vault, right? So the random pet.mysqllogin.id is a random pet name that I generate. That's then the username of the admin for the database server. And then you have the random password, which is it's the password that we use for that login. These two are saved to key vault, but then also used in the data source name. Then I use the fully qualified domain name from the flexible server, which is output, right, as input for the DSN. And then I use the DSN as input for the Kubernetes deployment, right? So here you can piece different things together without saving them outside of your Terraform code or anything like that. So it's all running on or happening at runtime. Gee, I cannot talk today. I'm sorry. All right, this is done. So let's go back to resource groups. Let's go to this one, and there we go. There's a MySQL flexible server here. So we go to databases as well. Then we should have a database, which is called Snippetbox. All right, good. So then if we go to the cluster, then the application should be there. Oh, hello, cluster. Oh, yeah, of course. There we go. All right, so pods. Yeah, we see the Snippetbox pod that came up like 3 minutes ago. So it's green. So everything seems to be all right. And then as we check its arguments here, let's see, here we go, right? Arguments, this is the DSN I just showed. And this is the DSN that we construct in Terraform using the pet, which in this case is a horse. Not really a pet maybe, but who knows? And then colon and then the password, right? Sorry, it stops here. Right, that allows the app to connect to the database server, and then it comes up and start running. So if we now go to Ingress, then we have both two here, right? So we have the vote app. Let's vote for dogs in this case, and do cats for Richard. I know he likes cats. And then let's open Snippetbox, and there we go. Like I said, there's not too much to see here yet, but it came up. So what it did as well, I created the Ingress rule. I used the cert manager to generate a certificate, and then used the nip.io. What is it? URL shortener? No, not really. URL alias, whatever. But yeah, this way, end to end, we were able to deploy the Snippetbox application besides the voting application by just adding that one line into customize, right? All right, see more. Let's see, more dogs and more cats. You know what? There we go. But yeah, that's what I have. Let's see, am I forgetting anything? Any questions? You see Nick is back. You want to kick me out or not? No, Nick's not back. No, not yet. I was looking at the paused stream. All right, so no, I think that's it. Oh, that's it. I'll stop sharing.
Yeah, so got no more question.
Yeah,
But Richard said toast tuna on Oreo is good.
What?
So it means that you explain it well. Good. So one question for me, Robin. What was that little thing you put at the end? Is that the port, the IP address at the end? Or is
Where?
it
What end of what? The DSN?
remember the URL? Yeah, is that the DSN? Of the URL, it's like an IP.
The fully qualified domain name. No, it's the.
Yeah,
I know. Now I know what you mean. Let me reshare.
How did you put that there?
Well, if you can use nip.io, so what you can do is you can grab a public IP address that you connect to. You can add .nip.io to the end, and then that's a domain name that you can request certificates for. Right. So you don't have to go into your own DNS, create an A record or whatsoever, right? You can just use that. It's pretty interesting stuff.
Oh, it's a nip.io. Okay. We've got a question from PSK.
Yes.
Is configuration drift detected and auto corrected by TF controller?
Absolutely. So it runs every 10 minutes. So that's the interval that is configured in the customization file. Let me briefly share that. We still have time anyway, right? So
yeah,
there we go. Let me switch. Otherwise, I'm sharing. It's a screen and a screen and a screen and a screen, right? So the Terraform controller is installed, and then on the Terraform resource, so in the application, right, we have a customization file. Let me close all these files just to make it a little bit more clear. So we have the customization file. Let's do this as well. Customization file, that's pointing to these two directories, right? Vote and snippet box. So in vote, there is a vote.yaml file, which is in this case a kind Terraform file. So Flux knows that this is for the Terraform controller. And here you basically configure the interval, which in our case today is 10 minutes. Right? So every 10 minutes, it will come up and then it will run Terraform plan. And if there are any changes, it will run Terraform apply. Right? And this is why we don't have to approve any plan, because you can configure that, right? Approve plan, auto. So, and then there's a lot of other stuff configured here, right? So this is how we can connect to Azure. I saw another question. I'll get to that one soon. This is how we enable workload identity on the Terraform runner. Then there's a custom. See, I forgot something. I should have explained this somewhere in the demo. But then we have a backend configuration which supports the Azure RM backend, right? Basically a storage account with the name of STN-NC AFC1. And then we have some variables, right? So if you implement this, then you want to use one repo for multiple environments, right? So then you want to change certain things that are environment specific, right? So for example, an IP address, or in this case, a ingress rule host name, or container image, right? In this case, it was V1, but maybe we want to deploy a different version in staging before we deploy that to production, right? So you want to be able to to control that. And the same for snippet box. But anyway, yes. Short answer is yes. It auto corrects and it auto reconciles as well. Yeah. All right, then.
What is the tool name which you use for AKS cluster dashboard?
This one is Lens.
Okay.
So this makes it easier. Okay, I meant configuration drift for cloud resource. So what do you mean exactly? Is that the cloud resources that we create outside of the cluster using Terraform? Because there are like two steps here, right? The first one is deploy the cluster and everything that we need so that we can start installing Flux. and then we have Flux taking care of the rest. Right. So this scenario where this would fit is I have a central platform team who runs a shared Kubernetes cluster, right? And we want to give development teams a way of deploying their apps, but also managing their infrastructure, right? So that we don't have to go and create that for them. Well, they can go do that, the ClickOps route. I already know that somebody showed me a sticker today. Don't do ClickOps, right?
Oh, yeah.
So that's not the way of doing this, right? There are other ways of doing this. So you have the Azure operator, right? Which you then can use YAML files to create these resources outside of your cluster. You can use crossplane. There are a lot of different ways of doing this, right? I'm a fan of Terraform. I really like working with Terraform. So doing this with Terraform makes more sense for me, right? So then the development team basically adds the files that they need, and then basically submits a pull request, right? That's then being reviewed by the platform team, and then when they approve that, then it ends up in the repo, and then Flux takes care of the rest. Right? It will take care of the infrastructure outside of the cluster, and then eventually it will deploy the application inside the cluster. Right? So Kubernetes then becomes a shared runtime rather than databases and stuff like that. So, all right, crossplane can provision infrastructure in a similar manner. When you choose Flux over crossplane, they both can do the same thing, right? So, for me, it doesn't feel very intuitive to define infrastructure in YAML, right? It makes more sense for me to do that in Terraform, and also with the extensibility and everything. And so I gravitate towards a Terraform and a Terraform controller. But yeah, we can achieve the same thing with crossplane.
I think that's all the question, Robin.
All right, good.
So,
and otherwise, hit me up, right? You can find me on LinkedIn. You can find me on Twitter. I'm more than happy to have a conversation and discuss whatever tech we want to discuss, right?
Yeah, I have another question, Robin. Why did you choose to store the backend config in YAML instead of like Terraform code?
Whoa. What do you mean? The backend config, what is that?
No, like for the state file and thus for Terraform itself. And it was in
a storage account, you mean? Instead of a secret?
Yeah, no, you define it in YAML file. You remember you define it here?
Well, this you mean?
This bit. No, these bit. Backend config. Custom auto configuration.
Oh, this is just how it works.
Instead of
this is how this is how
the
Terraform controller expects this field to be formatted.
Okay.
So it's not because I like this and write inline Terraform code in a YAML file, basically, but this is just what it expects.
Okay, that's fine.
Yeah. I hope that made sense. Was that clear?
Yeah, but you can also can you have to define this in the code here in YAML, or you can just put it in your in your repo and stuff with your code bases and stuff with Terraform, because you got the RM, you got all these. Yeah.
But this is YAML. This is Kubernetes, right? So this is the Kubernetes. This is basically a Kubernetes manifest file. Jeez, it's late already, but.
Yeah, because in a way it's kind of defining like Terraform code here, Azure RM resource group storage account inside this YAML file for Kubernetes.
This you need if you want to use a custom backend with the Terraform controller, then this is how you need to define that in your Kubernetes manifest file.
Okay, nice, thanks. So Bacchus said, awesome session. Okay,
thank you.
So thanks for joining. I think you explained quite well, so you got quite a lot of questions. So let's bring on the next guest. So next guest is Wesley and Richard.
Hello.
Hello.
Good session.
Hello.
Thank you.
Yeah, good session. Learned quite a bit from Robin. So everyone's quite learned a bit. So she got some questions. So it's quite cool.
Yeah, very good session.
Would you like to stay on screen, Robin, or you want to be off screen? I don't mind.
No, you can. Well, I like this. No, just push me back. Push me back. It's fine.
Go back to the green room.
Yeah. Go back.
It's gone. He's gone.
All right. So now we can talk.
Okay. Take it away, guys.
All right. Thank you, Nick. Welcome. I
Yep,
modified the slides. You see that?
I did notice. Yeah. So we should probably let people know. I created these slides for a talk, and we just ran out of time to rebrand them between us. So yeah, they're very Pixel Robots branded, but Wesley is here too. He's an honorary Pixel Robot today.
It's Pixel Robots and Wesley.
Yes.
But I was checking. Hold on. Look at my laptop. Can you see it?
Yes.
Where is it? Where is it?
Yeah,
There we go. Can you see it?
Very nice.
Yeah, got the Pixel Robot sticker.
Yep. And Alan, you're definitely right. The Wesley is too large.
All right. Thank you, Alan. So,
very nice.
all right. For the session today, we're going to be talking about scaling, right? We're not just going to be talking about node auto provisioning, but we're going to be talking about scaling in general.
Yes.
And looking forward to it. But introductions. Who's this guy?
This is me. Yep. So I'm Richard Hooper, also known as Pixel Robots Online, as you might get from the branding all over these slides. Principal Cloud Architect Intercept, who's a company based in the Netherlands, but I'm in the UK. Microsoft MVP and MCT. Even got the little blue disc on the MVP now, so that's like 5 years. Hopefully year number 6 soon. We just done the renewals. Cutoff was today, so we've got to wait till June or July. I can't remember.
July.
We'll find out.
July 1st.
July, yep. Oh yeah, 1st of July, yep. Usually gets pushed to after the 4th. And then, yeah, you can find me on Twitter, pixel_robots, or on the blog, pixelrobots.co.uk. That's pretty much me. Now it's you,
all right.
I think. Yes,
well,
it worked.
It's me. It works. I got your sheets. My name is Wesley, also Principal Cloud Architect, Microsoft MVP in the cloud native space on Twitter or X, W Hackman. Good luck butchering that. And check out my blog. But we're not here for who we are. We're here for provisioning, right? It's scale before you fail, I'd like to say. So the agenda for today, we're going to be talking about the Kubernetes scheduler that we all know, the Kubernetes cluster autoscaler that by default that we use, and then we're going to be talking about this brand new feature, AKS node auto provision, which is Carpenter, right?
Yeah, basically. Behind the scenes. Like the Wizard of Oz.
Yeah, but I think that's always that one thing that I thought I'm missing, that it was Carpenter.
Mm-hmm.
Now we
been
got
a
it.
long time coming.
It's been a long time coming. Well, we were at KubeCon in Paris, and well, obviously it was released a couple of months ago, and it became an add-on in January, I think. We got that in a slide somewhere.
In a slide somewhere, yeah.
But
and then when was it in Amsterdam? Which
exactly
was
that
over a year ago. They announced it, and yeah, it got pulled very, very quickly. Very quickly.
That's where I was going. I mean, we were at KubeCon in Amsterdam last year, and they were talking about Carpenter and well, an unnamed feature, and it was pulled, and well, we kind of knew what it was, and months later, we ended up with node auto provision.
Yep.
All right, so we all know about the Kubernetes scheduler, right? It's Kubernetes 101. Well, I'm saying we all know about that, but maybe you don't. It just you send a call to the API, you send some YAML, you want to deploy a container in a pod, and then the scheduler just looks at it and goes, all right, so memory, CPU, Windows, Linux, something, we deploy, right? That's what it does.
Yep.
Very basic.
The way I see it, it's a little man inside your Kubernetes cluster with a checklist and a map of your whole cluster. You get a request in, a new invoice or a new shipping container, comes into this little man, he looks at his little sheet of paper, checks it off, right? Okay, this one, go ahead and go over there because I got space over there. And that's how I see the Kubernetes scheduler, this little tiny man inside the cluster doing a lot of work for me.
I think the Udemy course for CKA, it's got like a really good video and example of how this works. If you want to get into the nitty and gritty of it, that session or that course is really good. Yeah, so if we talk about scheduling, we can talk about resource quotas, we can talk about affinity, disk dependencies, and obviously limitations, taints and tolerations. Personally, I'm a big fan of that, and topology spread. Basically, we're talking about where does your pod run and why. But then we talk about the why and then where does it run. That's what it does. It's
It literally just looks at your manifest file, which Robin was showing us quite a few of, which was quite nice in the previous session. And I did actually notice I didn't see any requests and limits, I think, if I remember correctly, in any of his manifests. So what the scheduler will do is look at that and go, oh, you can fit on any node, it's fine. But if you put your requests and limits, it goes, oh, right, okay, so you need half a CPU and half a gig of memory. I've got node 1, which has a quarter of a CPU available, so you can't go on that. But I've got node 2, which has a whole CPU available and enough memory, so you can go off on that one. And that's what this scheduler is doing. So request and limits are very important if you're working with Kubernetes.
And I think, well, that's a nice jump to the next one. When we talk about the cluster autoscaler, that's exactly what it does, right? I've got so much, I require so much CPU, I require so much memory. Is there a node that fits that CPU memory? But and that's the moral to the story here today. What if I'm requesting more than that a node in a SKU can provide me?
Yeah. What if you've ran out of all your free capacity in your cluster, but you want to put your new vote app because you've got a massive amount of people voting for cats, Robin, because cats always should win. So your app's now going to scale up because you've got thousands of people voting for cats and your front end can't handle it. And there's no capacity left in your cluster. So this is where this comes in.
Yeah. And then we have the cluster autoscaler, which by default you will have no Robin. It's not dogs, it's cats.
100% cats.
It's cats. And bunnies. I've got a bunny in the living room.
I didn't see bunnies on the list. Maybe we should do a new Azure vote with bunnies.
Yeah, we should have bunnies. We've got a bunny in the living room, and it's nice. All right, so the cluster autoscaler, if you've been using Kubernetes or AKS, you're probably familiar with it because it's used by the horizontal pod autoscaler, the vertical pod autoscaler, Kida. Who doesn't love Kida?
It's such a good product.
Probably one of my favorite products out there, Kida. And it just manages scaling. So you request something.
That's why I couldn't see him.
Terraform.
Wasn't in pure YAML. We should have it in the YAML. YAML all the way.
You got away with that.
Yeah.
All right. So what happens is you provision a new pod. It requires some CPU, some memory. It's not available on a node. You enabled auto scaling on AKS, and it will provision a new node in your VM skill set.
As long as you have quota, which is hard in some of the regions.
Yes. I think in the past months we've had some challenges there, and depending on the region, this demo, well, I'm gonna say this demo is in the UK because that's got more capacity, but I'm just using your README.
Nice.
So, it was easy, right?
Yep.
Copy paste. No, we've seen some challenges in West Europe, which is one of the regions where the new stuff is being deployed, kind of like East US too. It's also one of those regions that can be quite challenging. So yes, you need the quota. I think that goes for scaling in general. You have a scaling strategy. Make sure you have the quota. Whatever cloud you're using, we're talking about Azure today, whatever cloud you're using, make sure you have the quota available to actually reach that scaling limit. Having scaling technology does not mean you have the quota, and it doesn't mean that your strategy will be successful. So quota is part of that. Let's just see how it works, I guess.
Yeah, let's go to the demo.
Let's get to the demo. Demo. Okay, so here we go. I have.
Can you zoom in a tiny bit for my bad eyes?
No. Okay. What? This? Like that?
Yeah, perfect. Thank you.
That. Let me do the other one as well. That?
Yep, looks good.
Oh no, it is. I'm very. Yeah,
There you
that's it.
go.
Okay, so I've got two terminals. One where we can track what's happening. One where we can just launch the commands. Currently, I'm in my AKS CA demo UK cluster, which you can see here. Oh my posh, Pixel Robots theme. I just changed the colors, but good.
Yep, someone
theme.
didn't like the black and yellow, did they?
I did. This was for something Cloud Native Weekly.
Cloud Native Weekly, yes.
The colors, but it shows you the cluster that you're connected to, the subscription you're connected to, and even supports AWS if you're using it as well. But we're Azure, so I disabled all that. So connected to the cluster, and what we can do is get the nodes and get some details of the nodes. Let me grab that here. Just copy pasting from my README because then I don't butcher anything. So we've got a node pool and we have 3 nodes.
Yep. And what we've done here, we've used JQ to pull out the labels to make it easier. So otherwise you're scrolling through a lot of YAML. So yeah, we're just pulling out the labels that tell us what type of node pool it is. And as you can see, it's virtual machine scale set, and the VM size is standard DS2v2, which is your standard one with AKS when you just roll it out of the box.
Do we know top of mind what kind of CPU that has? Like 2 CPUs, vCPUs?
Two
vCPUs.
Yeah.
2 cores.
Maybe 4 gig of memory, something like that.
Something like that. But then, I mean, if we request something that's got more than that, that could be challenging, right?
Mm-hmm.
We're not going to do that today. So what we have is we have a namespace called inflate, and actually we have, oh, that was a bad typo. We have an inflate.yaml file here, which is a pod or a deployment with a pod that we're going to be deploying, and it requests 1 CPU and 256 megabytes memory.
Yeah.
256. Okay. So replica 0. So once we deploy this, nothing happens, right?
Mm-hmm.
Nothing.
And we're using the Kubernetes pause pod just because it's a pod that will constantly run and it just basically sleeps forever. It's very nice, lightweight pod.
So basically, so basically what we're doing here is we have a pod that does nothing, but it does request something, which is the CPU and the memory. That's what we're going to be doing. So if we were to apply this and do like that, then we still have inflate. We still have nothing. But if we do get deploy -n inflate, we do have a deployment, which nothing.
12 seconds ago. That's about right.
Sorry, 12 seconds ago.
12,
yeah, that should be fine.
Yeah, that's right.
Yeah. So in a different terminal, we're going to be watching what's going to happen, right? We're just going to press enter, and something should happen when we start scaling. So what if we were to set the replicas to 10, which means we need 10, what was it? 10 CPUs, right?
Yep. 10 cores of CPUs.
10 cores, yeah.
Yes.
So we did that, and now if we do kget pods, we can see some are running, some are pending, and if we look at our, I'm going to zoom out a bit, we can see that the cluster autoscaler said, hey, I'm triggering a scale up. I need more cores. I need more CPUs. So I'm going to scale up. In Azure, this would mean that the VM scale set that I have for my node pool is going to go from 3 nodes to whatever I need. I'm guessing
Maximum of
this is going
10.
to...
Because
Did we
that's
set
what
it
you
to 10?
Yes, we set it to 10 as the maximum
did.
amount of nodes you can go to. So it's going up to 3 all the way to the maximum of 10. So that's something with these VMSS things. You have to set your minimum and your maximum, and it's always tied to that VM size as well. So each node pool in your AKS cluster is a VMSS tied to one VM type. Some important information to remember there.
I'm just checking the AZ AKS create, and it says minimum count 3, maximum count 10. So this will go to a maximum of 10. This was done through Azure CLI. You can do it through the portal as well. But
Something for me,
Bicep,
question.
Terraform. Oh yeah, go on, Nick.
Why did it say trigger scale up? The reason is because it's being triggered by an event.
Yeah, so basically what we're doing here, we're watching the Kubernetes events with kubectl get events for all namespaces, and we're filtering that out just on the kubes scheduler, the cluster autoscaler events. Then Wesley says, I want 10 replicas. We knew our node pool had 3 nodes, each had 2 CPUs each. So that's 2, 4, 6 CPUs. We know our pod needs 1 CPU per pod. Wesley's now said, I want 10 of these. So that needs 10 CPUs. So there's not enough resources in the cluster, so it's going to add more nodes. And because there's all these system pods running inside the cluster already, like the core DNS and stuff, taking up CPU, what it actually means is we can only fit 1 pod per node, which isn't ideal. And that's why we've got 10.
yeah, we can see that here in the Azure portal. If I look at my node pool 1, it says target nodes 10, ready nodes 10. When we started, I didn't show that, but it was well, I did show that because
You showed it through the CLI.
I showed it here. We had 3 nodes. So we had 3 nodes with DS2 V2. And if we go back to the portal, we can see we've got 10 now. So we can then go back to the CLI and we do pause, everything is running. If we think, where was it? This one, we can see we've got more nodes here. We got 10.
Which is good.
So that's what the cluster autoscaler does. It just makes sure that it just deploys new nodes.
Alan has a nice message. Nick, can you bring that up so we can see? Yeah, there we go. So do we size the VM based on max workload size? So for this version, the cluster autoscaler, you would design each node pool to sort of fit your generic workloads as much as possible, because sometimes you could have pods that will have like 1 CPU, some that will have half a CPU, some that may only have 0.2 of a CPU. So you sort of have to figure out roughly how much you need based on all of your workloads together. Think of it like when you had your Hyper-V clusters or your VMware clusters, you had these physical boxes with a lot of memory and CPU. You had to sort of spec that based on what you could potentially ever use on it. It's the same with cluster autoscaler, except you don't have to go and do an order to HPE or Dell to get a new box with lots of memory. It automatically will add one for you via Azure APIs, which is nice.
Yeah, and on top of that, well, I don't want to go back to the VMware days or even mention VMware currently. I'm not sure, but
VMware by Broadcom.
By Broadcom, VMware by Broadcom. You heard it here on Azure Community Enthusiasts. So you've got requests and limits. You could technically also over provision like you used to do on VMware and Hyper-V. I wouldn't necessarily say do that, but you could. You could.
Definitely helps with the spin up time on the virtual machines, because VMSS is they're getting quicker. They're still not as quick as you can get some VMs in Azure. So, they have a lot of things they do when they spin up a new node in AKS. It bootstraps a lot of stuff. It sets up a lot of things. It joins the cluster and stuff like that.
And then we have additional features to spin up nodes more quicker, but you do kind of pay for the disk.
Yes.
You do size the VM based on the max workload size. And that is also the biggest challenge with the autoscaler, I guess. What if I need something else? I mean, if I need more CPU or more memory in a specific node, or I want to be more efficient, I think maybe it even boils down to sustainability. If I have one new specific workload that needs something else, do I deploy a whole new node pool? Do I standardize my whole node pool on that new SKU? Maybe not. We'll get to that in a bit. But
yep. And Alan's got another good question. The horizontal scaling is basically adding a replica. So if you think back to the days of IIS, your web server, you would add another web server to the farm. And the horizontal pod autoscaler with Kida can do that based on CPU metrics, memory metrics, service bus queue, RabbitMQ, AWS metrics, Kafka metrics, any metric you can think of, even HTTP metrics. It will add an extra replica. So it's just adding compute to your application, basically. So it could work out well with your node pools. That's how we all currently do it. It could work out bad because you could have some unused compute inside your node pools because of the size and stuff like that. Wesley's got a key to SH.
Yeah, I'm just grabbing documentation.
Yep.
You can even do it on Prometheus. Whatever metrics you have, Kida can do it, and then it uses the cluster autoscaler.
Yep. Nice.
Yeah, Luke is saying, love that. Think back to the days of infrastructure as a service.
Yep.
I think having a good understanding of how that works, VMware and Hyper-V, and basically hardware virtualization, having that knowledge and networking, troubleshooting, virtualization.
Yes,
if you have those three, Kubernetes is not that hard. It's the same thing. Well, I don't want to offend someone, but it's the same thing. It's just operating system virtualization. It's the same concept.
Yeah, I'll upset people. I don't mind. So I always think Kubernetes is definitely a platform for IT pros because we've been doing this kind of stuff for many, many, many years. Even application deployments. Think of your MSI files and your MSTs. They're just your container images and your YAML file and stuff like that, or your Helm charts. So we've been doing this for so many years. It's just got a different name. It's called Kubernetes now instead of Hyper-V or VMware. It's called a container image instead of a MSI. It's called a Helm chart instead of an MST. And, it's just the same as what we've been doing for many, many years, just technically easier.
Mate, I got my hair cut today, and they said, you're getting gray hairs, and now you're saying MSI and all that stuff. And
yeah. That's why you're getting gray hairs.
You're just confirming what's happening. Okay, back to the sheets.
Yes.
We're going to be talking about something else. Carpenter.
Yes, with a K, because Kubernetes,
Yeah.
Yeah.
It's it's a different approach, and I think we'll be seeing much more Carpenter stuff going on in AKS in the future.
Sure.
I think still, I don't want to offend people, especially not people using Carpenter. Just-in-time provisioning. I don't want to deploy a new node pool with a new SKU for just that single workload and just to revamp everything. I just want it for that specific workload, just in time when I need it. That should be.
Yeah.
That's what it is.
Helps keep the costs down and think of the sustainability, as you mentioned earlier. This is the tool to help with that.
Yeah, so I think this is also the answer to what if I have it's a weird example, but what if I've got two vCPUs or two cores in my node and I need 5?
Mhm.
Right? That's never going to work. If my request
Nope.
is 5, it's never going to deploy. If I use Carpenter, not Autoprovisioning, hey, there we go.
Here's a new VM for you, Mr. Hackman. That's just perfect for your workload.
I also love how you're not butchering my last name.
Yeah, I've worked with you for a long time, so
Yeah,
should be
that's
okay at
for
it now.
sure. All right. Yeah, so you could have done this last year, November,
Yep.
through Helm. But as of this year, you can do it as an add-on. You just enable it's in preview. You enable the feature, and it's there.
Yep.
You can use it.
Yeah. So in reply to Alan's question about how many pieces of extra software do you need, well, you have your AKS cluster, your Kubernetes cluster, and then you have this concept of managed add-ons from AKS, and you just enable that using the CLI, Bicep, Terraform, whatever language you want to use, Pulumi, and you don't have to manage that. AKS will manage that for you. So you don't have to worry about this software being installed. All you have to do is say, I would like this software. It actually uses Flux in the background, which is a good, reason to use Flux because Microsoft use it as well for their add-ons. And then, it's all managed for you. Every time you do an AKS upgrade, it will upgrade that version for you as well. So all you have to do is manage the AKS upgrade part, and you'll get the latest and greatest features of Carpenter Node Auto Provisioning.
Yeah. It's just-in-time provisioning, and I love just-in-time provisioning because I also play with Kaito a lot. Different session, different use case, but I love the concept.
That's all about AI. So if you're into AI, go find Wesley's session on that.
Yeah, Azure Lowlands. Check it out. Okay, not plugging anything here.
No. So another good thing about Carpenter is it doesn't use your virtual machine scale sets. So it just actually spins up virtual machines, which means it's a lot quicker. Whereas, and you have that just-in-time provisioning. So with the VMSS, the autoscaler method, you have to tell it what VM size you want to use. With Carpenter, you don't. You actually just tell it what family you need. So it could be a D, it could be a B if you're using burstable when you're doing some dev work. Could be an N if you're doing. Is it N for the GPUs? I don't know, but yeah, it could be an F series or whatever series you want. It could even be a collection of multiple different series of families in your VMs that you could want to use. And then Carpenter will go and query all of those available to you and then pick whichever one's best for your workload, which I really, really like.
Yeah, it does have some specific requirements, right?
Mm-hmm.
We're going to do a demo first, but I think we'll get to the use cases and limitations in a little bit. Let's just see how it works. Demo time. So first, what we need to do, we need to clear the screen because this doesn't look the best. It's kind of messy. We're going to change the context. I've already provisioned a cluster, the AKS NEP demo. We're currently connected to CA, cluster autoscaler demo. So we're going to be switching the context to NEP demo. Same here. And we can see it is all switched. So cluster's there, it exists. And
before we get to the demo, we've got another question. Yes, you can use spot nodes as well with Carpenter. If you use Carpenter with Kida, for example, and these can be scheduled as a cron job or something else like that as well. So onto the spot node. So 100% Carpenter works with spot VMs, which is really cool. Help keep those costs down even more. Oh, we've got another one. What's it? Is it good practice to have both HPA and VPA? I wouldn't use VPA in production. VPA I would probably only ever use when I don't know what kind of requests and limits I need from my application. And then I would enable that on a dev cluster, get some real world load testing going on, and then see what it does and see where it runs best. If you want a quick fix, I would probably always use HPA, because also with VPA, it can restart your pods depending on how your apps are written, because they might not be able to see all the extra virtual memory or CPU, so your app would need to restart to pick up the changes. So yeah.
It is kind of like I used to do this demo with Azure App Services, and then I would talk about vertical scaling versus horizontal scaling. It's like vertical scaling is adding more memory and CPU to your existing deployment, and depending on the technology in the backend, it might require the restart, so you can never assure there's no downtime. Horizontal scaling is adding more of what you already have. The biggest challenge here is, does your application support multiple replicas? We've seen it can either be that the application doesn't support it, whether you are the customer or you have a customer. The question is always, what if I run this twice simultaneously? Will something break, or will you get redundant entries in the database or something? Or in some cases, you need a license to run something with 2 replicas, or high available, as we'd like to call it. It's always a challenge, though. I'd have to say VPA, when you're talking about containers and pods, they're very small, they restart very quickly. The impact might not be as big as if you would be using like app services or VMs or something else.
Very true.
All right, I've got my terminal set up, and I am connected to my Node Autoprovisioned enabled cluster, which requires you to enable a feature because it's still in preview, which takes about 30 minutes. So if you start playing with this, make sure you have that. We can do nodes. We still have 3 nodes. They're ready. They're working. And we've got one of those lengthy commands as well. Let's copy and paste this and just take a look at 3 machines running again. Carpenter,
what you'll see here, that's an extra label. So because we've enabled Carpenter inside this cluster, we get this extra label. So this command that we're just pulling at, and you can see these 3 VMs are the system node pool, and they're running on virtual machine scale sets. They are not running Carpenter.
We can see that here. If we go to the node pools, this is what we're looking at. Node pool 1, we see that here. Node pool 1, DS2, V2. So, if you want to verify, we can see that here.
And you can see we've got that taint there. If you scroll up a tiny bit, right there in the blue. So this taint in AKS is a best practice. So you're saying your system node pool can only accept critical add-ons only. So only workloads that AKS have provisioned to make your cluster run. So this is a best practice. So if you are using AKS, make sure you do that.
And that would be Cube System, right? Anything in the Cube System namespace would probably run there. I'm not sure. Flux System, does it run on those as well? I think it does.
If you install it via the AKS add-on, it will go onto the system.
Yeah. I think I was playing with some image integrity and some Azure policy the other day, and you would see that by default they exclude some namespaces. Flux was one of them. Cube System, Gatekeeper System as well. That kind of stuff runs on the system node pool, right?
Yes. Yep.
Sorry, one question. Why is the Carpenter node pool null? Is it meant to be null?
Because we don't have one. We only have a virtual machine scale set, so there's none there. So that's why it's null.
So there's no VM. Okay.
Yep. There's just a virtual machine scale set, which is your standard VMSS, and we have no Carpenter ones. Lucy. He is like a little Pokemon. I need a little Pokeball to just catch him. Where's my Pikachu?
All right. So clear. Get back in the game.
Ah.
Wesley, get back in the game.
In fact, I have a crocheted Pokeball I
Oh,
can
come
throw
on.
at him next time he pops up.
Let me try to focus, man. Just
Okay, sorry. Let's get back on track. Back to the demo.
I'm gonna back to copy and pasting. So we're going to watch what events will occur looking at Carpenter, right? That's what we just put in.
Yeah, and this time we're looking for the source Carpenter, whereas last time we were looking
Yeah.
for the cluster autoscaler.
So if we go back to copy paste, and then we do this, Carpenter notebook null, we want something to change there, right?
Yep.
All right. So we still have that inflate.yaml over here. And what we're going to be doing is apply that inflate.yaml. And if we check that inflate.yaml, we can see replica 0, so nothing should happen. Fingers
Exactly the
crossed.
same YAML as the previous demo in the previous cluster.
Yeah.
Yep.
Saying fingers crossed because nothing happened.
That's because it's still 0 replicas. We need to now scale it to 10.
Exactly. Let's do that. Scaling it to 10. So it's scaled. Now we do kget pods dash and inflate, and we can see they are pending. If we look at what Carpenter is doing, pod should be scheduled on, and it's going to define a claim. And that's what we can actually look at. But now it's going to try and provision something that we need, right?
Mm-hmm.
And we can play with that. We can get node pools.
So
here's
these
an
two
interesting-
here, yeah, you go first.
System search.
Mm-hmm.
What's that?
It's a feature. It's coming soon. So at one point soon, we will be getting like system node pools that can run Carpenter. It might come at one point. I'm not sure when, but it's been in the Git repository and stuff like that. So they're working on it. They're talking about it. But the default one, I want to say, is something you only get with the AKS add-on. If you install Carpenter through Helm, you won't get that. So this is sort of Carpenter's way to do the node pools. You know, we had the node pool version, the idea of the node pools in the VMSS, the cluster autoscaler. That was a physical resource inside Azure, and now we put it inside the cluster to make it more cloud native, and it's called default. And you could probably describe that default one for us if you could, Wesley. I think there should be a copy and paste command somewhere.
Is it a copy? I was going to type.
Oh, you can type it if you want.
It is not a copy and paste.
Oh,
Okay, describe a node pool default, right? That's what you want.
yes. So here.
Oh no, you
earlier
get the MD. We have an MD. Don't
Yep.
worry about it. It's got a get node pools and it outputs the YAML. Same thing.
Same thing, yes. So this is your manifest file for your node pool. Rather than you have it in your Azure CLI or your Terraform, it's in YAML. And here, if you scroll down a bit more to the bottom of the spec section, you can see we're saying that's the status. So that's all of your potential CPUs and that. But we're looking at the D Carpenter.Azure SKU family is D. So that's all of your D ones. Where it says on demand, you can change that to be Spot. You can create a new node pool, call that Spot. You can change Linux to one day Windows, not currently because that's a limitation. AMD 64, you can change that to ARM at one point because we're still in preview. So these are the ways you can specify it. The families, you can even have, like I said, D, B, F, N, whatever in there, and it will just go through all of the ones you have available to you in Azure and pick the best resource for you.
And I'm trying not to butcher your name here. I'm sorry. Hari Pragash. What you asked about, can Carpenter be configured to schedule non-critical workloads, say on a Spot VM when available? I think this is when you can really talk about sustainability, right? You can have Carpenter just-in-time provisioning and then even use Spot VMs or go above and beyond. It's
really nice.
I know it's really nice. There's other solutions for Spot VMs. I think it was NetApp. Was it NetApp?
Yeah,
That did that?
Ocean by NetApp. Yep.
Yeah, and it's it really improved over the past 12 months, I have to say.
Yes.
So there's spot VMs. What's next? We can
Let's
get
check.
the node names, right?
Yeah, let's check the nodes. See if we got any nodes now. Because before in the cluster autoscaler, we scaled up to 10 nodes to run this workload because we only had 2 core VMs.
We have this.
But we've only got 1 VM this time. You know,
we
we
got
got
one.
the system node pool, but now we've just got 1. Why have we just got 1? In the cluster autoscaler, it scaled to 10.
Yeah, but what kind of node is it?
Yeah, well, let's have a little look. If you do the big long, well, you could just do that big long command again.
Oh, we can do the big one. Yeah, we can do that. But then we have to scroll. But
I don't know if you just up on your keyboard. There we go. Yeah, that one. And then you can see we have the one at the top, Carpenter Nopal, D16 ASV5, because it figured out it could run all of your workloads on a D16, and it would be cheaper to do that than it would be to run all of your workloads on the 10 different VMs where you won't even be using all your compute power. So it's decided to do that.
So, Richard, here's my question. I want to make sure that not everything runs on the same node.
Yep. So that's where
Because
your
now-
topology constraints can come in. Yep.
All right, there we go. So you can have the best of both worlds, right? You can have optimum sustainability, and you can make sure that not everything is running on the same node. Because if we're looking at zones, I mean, we had this thing in West Europe. What was it? A couple of months ago?
Last year sometime, where the wind decided to
something
drop
happened.
a tree or something like that. I don't know. There was a storm damage to some Azure data center, and it caused a zonal outage. That was fun times.
Yes. So zonal audit. Something happened. We don't know what happened. Something happened. Zonal outage. So you don't want everything, because obviously you want your nodes to run in different zones. You don't want everything to be running on the same zone or in the same zone. So it's next to this. You want to provide additional constraints. But just having this, it's absolute. It's perfect for node density, right? The amount of times that we look at node pools and the node density is just a lot of overhead, where going back in time, if we look at VMware Hyper-V, where we were, you would still have a lot of overhead. Not everything was utilized the way you wanted it to be. And with Carpenter and node auto-provisioning, you can get to that point, and still, if you use Kubernetes how it's supposed to be used, and implement your best practices, you can still have that availability like you want that.
Yeah. And just to add on that, one really cool feature with Carpenter is it will constantly keep checking your nodes and your workloads to make sure they're working on the best, cheapest, hopefully one day sustainable resource or node you can actually use. So yes, currently we may be on a D16, but say Wesley scales it down to 5 instead of 10. What it will do is actually, over a period of time, a few minutes or so, 10 minutes, it will say, right, I only have 5 workloads. A D16 is too much now. I'm going to drop it down to a D8 instead. And then it'll go off and do that. So you're constantly on the cheapest nodes. Whereas with VMSS and the cluster autoscaler, it's always going to keep that same node size no matter what.
And
that's what it's trying to do right there.
So scaling up and down, you want multiple nodes, you want some redundancy, you can play with that, but I think this is also the answer to running an additional specific workload or peak workloads, if you will. It kind of reminds me, you remember when we had the ACI bursting? I think it still exists.
Yes, it's still around.
Kind of that, but better.
Yeah, to an extent, yeah. Obviously, with ACI bursting, you still have the pay per second, whereas this is per hour, but you could probably figure it out, and it could probably be cheaper still if done well.
I think I'd probably favor node auto provisioning over ACI bursting, not just because of pricing, but performance.
Mm-hmm.
ACI has its limits. I mean, it's good. If you know what you're running, ACI bursting is great. If you don't know how much of what you're running you need, probably go with node auto provisioning in the future when it goes GA.
Yeah, we just got another good question from Alan. He says, can you do cross regions for HA? There is a way, and it's called Fleet Manager for Kubernetes. So it's a resource inside Azure, which can control multiple different clusters. So you can't have your node pools over different regions, but you can have multiple clusters over different regions. And then the Fleet Manager will control both of those, can help you with manage all the updates and even spread your workloads over different clusters for you. So that's probably a good session to do one day, but way out of scope of this one. But it is possible to do things like that.
We could do one.
Yes, we should probably do one.
Yeah.
But yeah, limitations of that, because it is in preview, there's a few, and there's more than what I have on this slide. But these are the biggest ones. One thing has changed though, Azure Linux is now supported. Windows still isn't.
But as long as Linux is, we're good.
Yes, because
we want Windows support at some point.
Yes, one point. But if Windows containers are a very good stepping stone into the world of containers and cloud native technologies. It can help your developers prolong the life of an application whilst they're rewriting it. So it's a good stepping stone for sure.
Oh, I should start saying that.
Good.
Prolong the life of. Yes, I agree.
Yeah.
Maybe I should start saying that instead of what I normally say.
Yeah, maybe.
Yeah. Okay.
Yeah.
Okay. New clusters. Yeah, versions, right?
Yeah. So there is a way to update an existing cluster, but it can't have cluster autoscaler enabled. So I just say, if you're starting out with this demo and this practice and preview, just do it with new clusters because it will make your life easier. At GA, hopefully it should have support for upgrading.
All right. Private cluster. Well, we've been to the pre-day. We have some opinions on that. Will it ever be supported? Not sure.
Probably at one point, but there's some dodgy networking behind the scenes that is way out of scope. That probably needs to be done first to get the cluster talking to the APIs properly to spin up private nodes and stuff like that. But yeah, I'm sure one day it will come, but way out of scope of my skill set on networking. But it'll be there, I think.
Unable to start. You think they'll ever come? I think it's mainly because of the difference in technologies, right? Instead of managing the VM skill set from AKS, which we normally do, it's now a VM. It's not a skill set, right?
Yeah, I feel like instead of start, the VM will just go and it'll just spin up you a new VM. Maybe at one point you'll be able to pin it to the VHD image version, and that's when you can do start. I don't know. That's just speculation, but I believe it will come because it's a good way to save costs on dev clusters. Some other limitations, which I don't think are really limitations, but these are the things that you should know about with node auto provisioning and Carpenter is the version of Kubernetes is always tied to your control plane. So with the VMSS one, you could have N-1, 2. As you're upgrading your control plane, you can have your node pools at a different version to your control plane. Node auto provisioning will just keep that up to date for you automatically, which is nice. And it also keep updating your node images for you. So every time there's a new node image, it will just update that end cycle for your pods. So if you have pods that maybe just one replica and you don't really want downtime, don't look at NAP just yet. Update your app first and then look at NAP.
Spread topology.
Yeah, get some multiple replicas going, pod disruption budgets, and then Carpenter or NAP. But apart from that, it's really
PDBs.
cool.
You want to talk about PDBs now? We don't have much time left.
No, we have no time left for PDPs. We probably overran already by the looks of it. So that was all the chat about cats. So we should probably stop here.
Awesome.
Unless there's any questions, obviously. Nick's
Nope.
back.
No more question.
Oh, there's Nick.
Awesome.
Hello.
Hello.
But yeah, if
No.
anyone has any questions after watching this, if they're watching it on YouTube, Twitter, or whatever, just reach out to us, one of these, or Wesley on Twitter as well. Or get to me to get to Wesley. I'll let you straight through. It's fine. I will not put up a fight.
What now?
Yeah, no, nothing.
All good.
Let's bring back Robin. Robin's back on the
Yes.
stage.
Hello.
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 You've got any question for Richard?
No. I'm worried about. Okay, there we go. It's better. I've been messing around with my setup while I was in the green room to see if I could isolate the issue, but it seems to be gone now. But who knows?
Yeah, it's good. Sound is good.
This sounds good to me.
Yeah, but no questions. We had this session before.
Yep.
Well, Richard did
Yeah.
this session before, so
Yeah.
no question. But thanks for pulling me back in.
It's always good to see you.
Thanks, guys. Thanks.
Yeah.
Okay.
Cool. Right, Nick. Do you want to close this out?
Yeah, so if there's another question, just let me play some intro for the next episode. So 1 minute. Bye, guys. So that was